Hi, questions in analysis in this textbook. Find an example of 1. Two divergent sequences that their product is a convergent sequence. 2. Two convergent sequences that their quotient is a divergent sequence. 3. Sequence xn such that the limit xn equals 0 and the sequence nxn is a unbounded sequence. Solution. Example 1. The sequences xn, yn are defined by those two. Then xn and yn are divergent. Their product is a convergent sequence. If these two sequences, then the sequences xn and yn are convergent, but the quotient is a divergent sequence. Consider this sequence. The limit of this sequence equals 0. The sequence nxn is an unbounded sequence. 1. If limit xn equals a real number x and the limit yn is infinity, show that the limit xn plus yn is infinity. 2. Show that this limit equals 0. 3. If xn is a sequence which converges to 0 and yn is a bounded sequence, show that the sequence x and yn converges to 0. Solution. Question 1. Let m be a real number greater than 0. Since the limit yn equals infinity, there is n1 greater than 0, such that for all n greater than n1, y is greater than m minus x plus 1. Since limit xn equals x, there is n2 greater than 0, such that for all n greater than n2, we have this inequality. Then, when n is greater than the maximum of n1 and 2, xn plus yn is greater than m. This implies the limit xn plus yn equals infinity. Sorry, here is a typo. Question 2. Note that the absolute value of sin x is equal to or less than 1. Then we have this inequality for all positive integer n. For any epsilon greater than 0, there exists n equals 1 over epsilon, such that 1n is greater than n. 1 over n is less than epsilon, so that this one is less than epsilon. This implies this limit. Question 3. Since yn is a bounded sequence, there exists a real number m greater than 0, such that the absolute value yn is less than m for all positive integer n. Let epsilon be a real number greater than 0. We have this inequality. Since the limit xn equals 0, there exists n greater than 0, such that the absolute value xn less than epsilon over m for all n greater than big N. Thus, we have this inequality for all n greater than big N. This implies this limit. Thanks for watching. Bye.